Today we will learn about characteristics of a wave. So before going through the topic, just let us revise that sound travels through a medium. Either it can be solid or liquid or gas. So sound travels in the form of a longitudinal wave. So here we have a diagram of wave. So this is a graph where y-axis is showing wave disturbance and x-axis is showing time. So as we speak, there is a disturbance created in the particles of air. So due to which we can see the particles will come near to each other, called as compressions, and if the particles are far away from each other, we are calling it as rarefactions. So visual representation of this disturbance or vibration is this form of wave graph. So here we can see that there is a peak called as crest where the particles are compressed. The disturbance is maximum and due to high pressure created due to vibration or disturbance, and this can be rarefaction, value of rarefaction, where this value we are calling it as trough, and one crest, one trough and one crest makes one cycle, which is called as one period or one oscillation or one vibration, or we can say as one compression, one rarefaction and again one compression makes a cycle. So coming to the height of the wave, it is calculated from the peak of the crest to the equilibrium, which is called as the amplitude. And frequency. Frequency is the number of waves per unit time. So coming to the formulas, so we have velocity is equal to distance by time. So units are meters per second. And velocity is equal to, or speed or velocity is equal to wavelength into frequency. Frequency is represented by the symbol nu, and units of velocity or speed is meters per second. Next we have lambda, which is wavelength. Symbol of lambda is this, which is equal to V by nu. So lambda is measured in meters, which is wavelength. So from here to here, from one peak of one wave to the other wave, we are calling it as wavelength, represented by the symbol lambda. Later on, frequency, which is equal to 1 by t time period, or time period is equal to 1 by nu. So nu is the frequency, t is the time period. So time, as you know, it's measured in seconds, nu in hertz, frequency is measured in hertz. Then we have a formula, velocity or speed is equal to wavelength into frequency, which is equal to wavelength into, instead of nu frequency, we can substitute 1 by t. So V is equal to lambda by t. Sometimes this formula is also useful when time period and wavelength are given. One wave is equal to one crest plus one trough. That means two waves is equal to two crests plus two troughs. So these are the some of the characteristics of the wave, labels of the wave and formulas. Coming to the characteristics one by one, let us see. Loudness and softness of the sound. So how do we determine loudness and softness of the sound? So when taking y-axis wave disturbance and x-axis time, see the difference. Here this is a graph of soft sound and here this is the graph of loud sound. If you compare the amplitude of loud sound is less, soft sound is less and loud sound is more. That means more the amplitude, more is the loudness of sound. Less the amplitude, less is the loudness of sound. It means soft sound. The amplitude is nothing but height of the wave, which is measured from the peak of the crest to the equilibrium position. This is regarding loudness and softness of the sound. Next is pitch. So this is a graph showing low pitch. Example, guitar. So y-axis wave disturbance, x-axis time. If you compare both, the frequency of low pitch guitar is less when compared to the frequency of high pitch guitar. See the number of waves. The number of waves are more in case of high pitch. In case of whistle, low pitch, the number of waves are less. So the frequency is less for guitar and more for whistle. Hence guitar has low pitch and whistle has high pitch. Next, one more is timbre. Timbre gives the quality of the wave or timbre. So it is a quality of a musical sound which is used for differentiating two sounds when they are in same frequency. That means they have same frequency, but the source produced from where the sound is coming is different. For example, tuning fork, flute, voice, violin. So here the frequency may be same. That means the number of waves passing per unit time may be same. But the material through which the sound is produced is different. So there we can differentiate quality of sound from tuning fork, flute, voice and violin. Next, coming to the numericals. So let us see first problem. Calculate the wavelength and time period of tuning fork of frequency 512 Hz. So from units you can know that frequency 512 Hz is a frequency which is set to vibrate. Velocity of sound in air is 320 meters per second. You know, the tuning fork, when it is disturbed or it is set to vibration, so it moves with certain frequency which is 512 Hz, and velocity of sound in air is, speed of sound in air is 320 meters per second. So first we have to write the given data, which is important. Then we have to solve it by writing the appropriate formula. How to know which formula to be used? Here given V is equal to 320 meters per second and U is equal to 512 Hz. So we are asked to find out lambda. As two factors are given, that is velocity and frequency, the third factor will be the lambda or the wavelength. So we can use this formula and find out the wavelength, which is nothing but 0.625 meters. Again, units are important at the end. Now to calculate the time period, T is equal to 1 by nu, which is equal to 1 by 512, which is equal to 0.00195 seconds. So this way, when two factors are given, we can find out the third one, and by substituting the value, frequency, even time period can be found. Coming to the next problem. A person observes smoke from a gun of 1.4 seconds before he hears the bang. If the gun is 476 meters away from the person, find the speed of the sound. So the given is distance, which is equal to 476 meters, time is 1.4 seconds, and we have to substitute in the formula velocity is equal to distance by time. Very simple problem. So distance is 476, time is 1.4 seconds, which gives velocity which is equal to 340 meters per second. Then next type of problem, what is the frequency of sound wave whose time period is 0.05 seconds. So given values are t is equal to 0.05 seconds, when nu is equal to 1 by t. So when we substitute the value of time period, we get the value of nu, which is nothing but 20 Hz.